Well, hello everyone. Harsh Verma this side, and today in the day second of understanding about the OSPF. So we are not understanding OSPF by way going very deeply to the topic, but with the context of outline of the book Network Warrior. So according to our last video, we have understood what an OSPF area is, what is the OSPF priority, how does it determine which router will become the designated router. But upon recalling, I think that I have left the topic at last because I have to go somewhere else. So, without any further delay, let's continue our session. And this is the book that we are going through. The book name is Network Warrior Everything You Need to Know That Was Not on CCN Exam. This book does not explain everything in detail but outlines the topic or the practical lessons that was missed during our CCNA preparation. So without any further delay, let us search into my phone. So ideally, we have in the last chapter, we have already studied about the different area types, the backbone area, non-backbone area, the types of normal area, stub area, what are the differences between totally stub area, not so stubby area, or not so stubby, totally stub area. I have already told you that sometimes these things to be remembered because it's not used very extensively, but it just have to kept in mind. Okay, so now our topic for the day, or in order to continue the studies, we have the OSPF interface priority. The OSPF interface priority ranges between 0 to 255. 0 becomes the lowest and 255 becomes the highest. Unlike the STP, spanning tree protocol, lower priority is not preferred here. After all, normally the default priority of a OSPF router is 1, while 255 priority means the highest priority, and the router having the highest priority will become the designated router, while 0 priority means it won't become the designated router at any cost. Okay, now to set the OSPF priority, we can use the command IP OSPF priority or a range or a value between 0 to 255. And upon the tie of router priority, then router ID is used to break the tie. For example, every router has a default priority of 1. If we connect to router and start the OSPF process in it, the router priority will get a tie. So in order to break the tie, we going to use or the OSPF process uses the router ID, and the router ID is the highest IP of any loopback interface. Let me confirm it whether it is the highest IP or the lowest IP. Or router priority or router ID. Let me Google it. Not Google it. Let me ask it from an AI. Mostly, I will ask it using Claude. Okay. So router ID is highest or lowest? Lowest loopback ID. Loopback IP address. Continue. Okay. So as I mentioned, the router ID is typically the highest loopback IP address. So let's switch back to our terminal. Yes, router ID can also be manually set using the command router-id and the IP address. So router ID is also a 32-bit value because it is in the same format such as IP address in the 4 octets separated by full stops or periods. Now, command it will automatically assign based on the IP address of the highest number of loopback interface. So that's it. Router-id command take effect after restarting the OSPF process. So by default, if OSPF automatically gets a router ID due to highest loopback interface, and we want to change it, so we have to restart the OSPF process. Ideally, restarting router is not ideal in every scenario. So what we can do is we can just restart the uh, router OSPF process in order to refer to the new router ID. Next, ideally WAN should be placed in area 0. The WAN is the connectivity of upstream. Basically, WAN may be your ISP or maybe some other gateway router from which you are getting the internet on that particular router on which we are running OSPF. So basically, the recommendation is to place the WAN in the area 0. So the first router that connects to the internet should be in the area 0. Okay. And now we have to study the network types. which are supported in OSPF for the day. So the network types supported in the OSPF are point to point, point to multi-point, broadcast, and non-broadcast multi-access. Let's understand what are these. So point to point network are simply when you connect two routers with a single cable and there is no other routers connected between them. It may be that one branch office is connected to another branch office with an fiber link. So because there are only two nodes, there need not to be have any designated router or backup designated router election. Okay. Now, in case of point to multi-point, which is an often scenario in which a main head branch advertises its network to its multiple different branches, it may be some due to some wireless configurations, etc. Or we can say if it is due to connectivity using hub, in which one main router is advertising to other multi router, but those routers are not connected with each other. So in that case also there is need not to have any designated router or backup designated router election, because there is no path of chaos, only connectivity is between one router and multiple routers, but the connectivity is between the router A and router B, router A and router C, just like that. Next, in the broadcast network scenario, which is the most common scenario that we use, for example, the Ethernet, the Wi-Fi, everything or the mesh networking is also part of broadcast. So broadcast is just like regular Ethernet. It may be in token ring or FDDI network. So these are form of network, a topology type. So okay, but I'm not looking that now. So in this scenario, the designated router and backup designated router election must should take place, because in these kind of scenario, if we don't elect these designated router and backup designated router, the network may be chaotic for the calculations, because every router then have to calculate its shortest path and every router has to share its finding. So the network itself become chaos and there will be no or little space left for the actual data to flow. Now the last thing is multi-access, in which multiple nodes are there but not on a single medium, and they default for frame relay or X.25 and SMDS, which stands for Switch Multi Megabit Data Service Network. I have yet to see this form of network. So, ideally, a better chance or a better idea to actually Google how frame relay works, how X.25 works, or how a SMDS network works. I will be doing so. So, let me works, or we have to ask about frame relay topology. How frame relay works. How does frame relay work? A frame relay is an standardized wide area network technology that specifies the physical and data links of digital communication channels using a packet switching methodology. Okay, so frame relay was originally developed as a simplified version of X.25 system, which is carried over the emerging service digital network SDN. Okay, soft kind of service digital network, not software defined network. Okay, and this is the graph or example of frame relay network. So frame relay is kind of a black box in which one equipment terminates to the ISP, and then ISP will switch packets somehow. So we don't know where the packets are coming from, but for sure there's a 2 point that if we send something from this side, other side will definitely receive some. Have to control or have a clear pathway from where the data is been coming through. Frame relay works by breaking data into smaller units called frame, which are transmitted over a network using the packet switching method. It established virtual circuits between endpoints, allowing multiple users to share the same network infrastructure efficiently. So that's it for frame relay. And yes, there's a show command, which is the show IP OSPF databases command to show the OSPF databases. And also, I want to add one more thing. If we run OSPF process for a particular VRF, as we learned in the VRF chapter, we can already append the VRF, not append, prefix the VRF command, VRF with the name of the VRF process, and run the same commands, router ID, so IP OSPF databases, and it will show the database for the particular VRF. And that's it for this video. Thank you for joining. Thank you for watching.